Gas. In the infancy of the petroleum industry, it was flared, vented, cussed, and generally considered a nuisance. Yet today, gas is one of the world's primary sources of energy. Now, when most people think of natural gas, they think of the gas they use to cook or to heat their homes. Now, what they don't realize is that when natural gas is first produced, it is usually a combination of several gases: ethane, butane, methane, to name just a few. In order to sell this gas, a way is needed to measure the amounts of each gas present in a particular gas stream. This is done by sampling. Now, sampling, as defined by the Gas Processors Association, is obtaining a representative sample of a hydrocarbon stream. The key word in this definition is representative. A representative sample is a small duplicate of the product as it flows through the pipeline. Once a sample has been taken in the field, it is delivered to the laboratory for testing. Here, lab technicians pull a portion of the sample to measure the percentages of each hydrocarbon in the gas stream. They check for percentages of H2S, CO2, and water in the various samples. Gas is also evaluated for its BTU, or British Thermal Unit value. All of this information is processed, and decisions regarding sales contracts, reservoir studies, property evaluations, enhanced recovery programs, and engineering for new facilities are made. So you see, an inaccurate sample can cost millions of dollars in lost revenue, contribute to the improper design of plants, or cause improper plant or pipeline balances. An accurate and representative sample of the gas and liquid flowing through the pipeline is important. You just can't go out and grab a sample anymore. So let's look at the equipment and procedures necessary for taking good gas and liquid samples. This is the first section of a 3-section module dealing with the fundamentals of gas and natural gas liquid sampling. Samples are collected in a device called a sample cylinder, like this one. Care should be taken to have a cylinder that is of a proper working pressure and made of a material that will not react with the sample. This is usually stainless steel. The sample cylinder also must be cleaned properly with a solvent such as acetone or trichloroethane, then steam cleaned and air dried. If a sample cylinder has not been cleaned properly, oil, grease, or other contaminants in the cylinder may absorb some of the heavy hydrocarbons in the sample, resulting in an inaccurate sample. The hand valves and relief valves installed on sample cylinders should be checked to see that they are the proper working pressure and non-reactive with the products being sampled. Proper maintenance of these valves is important because of the problems that can occur if the cylinder should leak. A leak of any type creates a sample which is not representative of the flow. Finally, all sample cylinders must be in a container that will protect both the valves and the cylinder from damage or loss of the sample when it is transported. This is a requirement of the Department of Transportation. The sample should also be accompanied by a properly completed Department of Transportation shipping form. Remember, improper transportation is a safety hazard as well as a violation of the law. When taking a gas or natural gas liquid sample, 3 critical areas must be controlled: pressure, expansion, and stratification. First, pressure must be controlled to collect a sample without allowing the composition to change. If back pressure is not maintained, the light ends might flash. Flashing occurs when the pressure changes, creating a 2-phase sample and altering the composition of the sample. If the pressure is allowed to rise, it can also rupture the relief valve, and part or all of the sample can be lost. Expansion occurs as the ambient temperature of the sample increases. Problems due to expansion usually occur with NGL samples. This can be a safety hazard if the sample has no room to expand within the sample cylinder. The end result could be a ruptured cylinder which could explode like a bomb. To allow for expansion, outage is usually needed for NGL samples. Outage simply refers to creating a space within the sample cylinder by bleeding off displacement fluid. One final problem which can occur with sampling is stratification. Mixtures of hydrocarbons, if left long enough in a sample cylinder, will stratify or layer. A sample drawn off a stratified cylinder produces an inaccurate sample. Therefore, the cylinder must be mixed before a sample is drawn. Further, the sample cylinder should be analyzed as soon after sampling as possible. In order to collect an accurate sample, a proper sample point must be located and a probe installed. The sample point should be located in the section of the pipeline that has a constant flow and a minimum of turbulence. In gas sampling, the tap should be located on the top of a horizontal section of pipe. In liquid sampling, the tap should be located on a vertical section of pipe. If on a horizontal section, a static mixer should be installed upstream of the sample point. Sample points should never be located near meter manifolds, blowdown stacks, pig traps, headers, or any type of dead-end line. Samples should never be taken around or too close to obstructions, control valves, orifice plates, elbows, tees, or other fittings that might generate a stream composed of gas and liquids, commonly referred to as aerosols. Once a sample point has been located and a tap installed, a probe should also be added. A probe is usually a stainless steel tube installed in the line which has a beveled end aimed upstream to gather the sample. Because of the nature of flowing streams, both gas and liquids, the sample should be taken in the middle third of the pipeline. There are three basic types of sampling: spot, incremental, and continuous. Of the three, spot sampling is the most common. In spot sampling, a sample is collected at a particular location at a specific time. Incremental sampling involves taking a sample in predetermined amounts over a predetermined length of time, usually 2, 4, 6, or 8 hours. This method is more commonly used in test situations. Continuous sampling uses a specially constructed sampler which takes a set amount of sample in proportion to the flow volume. Although continuous sampling is not as common as spot sampling, it is the most accurate sampling method. However, because of the cost of continuous samplers, this method typically is used for high volume or ethane-rich flows. This concludes the first section of our module dealing with the fundamentals of natural gas and NGL sampling. Take a moment now to review your manual, preview this section of tape again if necessary, and take the test that follows. In our next section, we will look more closely at the equipment and methods used to sample natural gas. In our last section, we discussed the basics regarding sampling. You saw why we sample and why it is important to collect good samples. We also discussed the three basic ways to collect samples. In this section, we will look more closely at natural gas sampling. This is the second section of a three-section module dealing with the fundamentals of natural gas and NGL sampling. Before you pull a natural gas sample, there are some general rules which need to be pointed out. 1. Samples should be collected at stabilized flow conditions. 2. The temperature of the sampling cylinder should be equal to or greater than the gas temperature. 3. Before any sampling lines are attached, all accumulated liquid and solids in the sampling point valve should be blown out by venting some gas through the valve. As mentioned in the first section, stainless steel cylinders are also used to lessen the problems of surface absorption of heavy components as well as the reaction of acid gases within the cylinder. They may be designed only to take gas samples or built to be used for gas and NGL samples. Remember, always be sure that cylinders, valves, and tubing have working pressures equal to or greater than the maximum possible pressures which may be developed in sampling, storage, or transportation. In either case, the size of the container depends upon the amount of sample required for lab tests. Sample cylinders are usually connected to the flow lines in one of two ways. Some locations have a fitting permanently installed where the sample cylinder is directly connected. At other locations, the cylinder is connected to the flow line using a flexible tubing. Stainless steel tubing is preferred. However, a non-reactive metal tubing like copper or steel may also be used. Sometimes entrained liquids are possible at the sample point. When this occurs, a liquid separator may be required between the sample point and sample cylinder. The separator is used to remove liquids which may cause a non-representative sample to be taken. To avoid contamination, the separator should also be made of stainless steel. One final point before we discuss natural gas sampling methods concerns identification. All samples must be identified and tagged. This information is needed before a sample can be handled in the lab. These sample tags should include certain basic information along with any special instructions or remarks which may help lab personnel to properly handle and analyze the sample. Some of the typical data needed are date and time sampled, sample source, location, well, lease, plant, method of sampling, name of the individual taking the sample, separator or line pressure and temperature. If the sample is taken at a point remote from the actual separation vessel and the temperature and or pressure are different, both separation pressure, temperature, sampling point pressure, and temperature pressure should be given. Sampling pressure, if taken at a reduced pressure. Gas gravity and H2S and CO2 content if run in the field. Sampling container identification number, and any analyses to be performed. Sampling into an evacuated cylinder is the most commonly used sampling method for gas and applies to both dry and wet gases. However, there are also several other methods which are applicable under certain conditions. These three methods are the evacuated cylinder method, the purge method, and the fluid displacement method. Detailed procedures regarding these methods can be found in the appendix of your student manual. For now, let's just look at each of these methods in general. In the evacuated cylinder method, a sample cylinder is cleaned, dried, and evacuated. Now, evacuating a cylinder basically involves removing the air from it through the use of a vacuum pump. The cylinder is attached directly to the sample point with a manifold. The sampling line valve and manifold valve are opened and the sample is taken. The purge method is more suitable for dry gases where there is little chance for condensation. After the sample cylinder has been attached to the sampling valve, a sample is taken and then bled off. This is called a purge. Depending on the line pressure, you may have to purge the sample cylinder a number of times before you get a good sample. Finally, there is the fluid displacement method. Though normally used for liquid sampling, the fluid displacement method may also be used to sample gas. However, if you use this method, the fluid being displaced should be warmer than the gas being sampled. Sampling by this method requires that a sample cylinder filled with fluid, usually glycol, water, or brine, be attached by tubing to the sample valve. In the past, mercury was sometimes used as a fluid, but is no longer recommended. After opening the sample valve and inlet valve to the sample cylinder, the outlet valve is slowly opened, bleeding out the displacement fluid. Because you are sampling gas, all the displacing fluid may be bled out. Because resampling is often difficult or sometimes impossible, duplicate samples should be taken. Duplicate sample cylinders are connected in parallel and filled simultaneously, usually using a manifold. This concludes the second section covering natural gas sampling. In our final section, we will look at natural gas liquid sampling. Take a moment now to look over your student manual. View this tape again if necessary, and take the test at the end of this section. In the second section, we talked about the equipment and some of the procedures used in obtaining a natural gas sample. In this last section, let's look at the equipment and procedures used in obtaining an NGL, or natural gas liquid sample. This is the third section of a three-section module dealing with fundamentals of natural gas and natural gas liquid sampling. As with natural gas samples, there are some general rules you need to follow for sampling natural gas liquids. 1. Samples should be drawn from points on the line or vessel having a constant flow. 2. The probe should be sampling from the middle third of the pipeline. 3. To ensure a representative sample, a static mixer may be installed upstream of the sample point. 4. Liquid samples should never be taken from the top of a line. 5. Be sure to vent some liquid from the sampling valve before drawing any samples. 6. The temperature of the sampling cylinder should be lower than or the same as that of the sample to prevent flashing. To avoid possible rupture of the container or safety device caused by temperature increases during transport or storage, liquid sampling with the displacement method requires that outage be taken. Outage is simply creating a space within the cylinder by bleeding off a portion of the displacement fluid. At least 10% of the volume of the sample container is needed. Outage must be displacement fluid, not part of the sample. There are 2 types of sample cylinders used for NGL samples. The most common of the 2, like this one, can be used for either gas samples or NGL samples. In some locations, however, other sample cylinders are designed only for NGL samples. As with gas samples, all liquid samples must be identified. The typical data needed for tagging liquid samples include the date and time sampled, the sample source, the location of the sample, a well, plant, or lease, the method of sampling used, amount of outage, volume of the sample, the name of the individual drawing the sample, the sample container identification number, type of displacement fluid, the separator or line pressure temperature, oil gravity, and any analyses to be performed. The 2 most common methods of NGL sampling are the fluid displacement method and the floating piston method. Sampling by the fluid displacement method requires that a sample cylinder filled with a displacement fluid, usually glycol, water, or brine, be attached to a sampling valve by tubing. The sample is drawn by bleeding the fluid and replacing it with the sample. Unlike gas, outage is necessary to prevent cylinder damage or loss of sample through a relief valve or rupture disc. The floating piston method of liquid sampling is similar to the fluid displacement method, except that a floating piston within the cylinder helps to maintain the integrity of the sample by separating and preventing the absorption of sample components within the displacement fluid. A more detailed discussion of both the floating piston and fluid displacement methods of NGL sampling can be found in the appendix of your student manual. In this module, you have learned the importance of sampling and the types and purposes of samples. We've looked at the equipment and procedures necessary for good gas and liquid samples. Take a moment now to look over your manual, review this tape again if necessary, and take the test at the end of this section. Remember, sampling involves more than just going out and grabbing a sample. Millions of dollars in both revenues and savings are determined by that small representation of product in your sample cylinder.